Today in class we discovered that every angle of rotation, when it ends on the unit circle, the coordinates of that ending point that are on the circumference of the circle are a combination of the cos of the angle, comma, the sine of the angle. Now that is not only true just for your multiples of 90, it's true for any angle of rotation. So on my unit circle here, I have rotated to 45 degrees. And we're going to figure out the coordinates of this end point out here on the circumference of the circle for 45 degrees. And we're going to come up with those xy's, or those cosine, by drawing our triangle that's going to contain my reference angle. So here's my right angle. And if this angle of rotation was 45, that means this angle up here is 45, which means that these two sides of the triangle are the same size. And we also know, since this is the unit circle, that means the radius of this circle is 1, so that means the hypotenuse of this triangle is going to be 1. So we can figure out the distance from here to here along the x-axis, and we can figure out the distance from the x-axis up to that point that's on the circle. And we can do that by using Pythagorean theorem. So I'm going to flip this to the next page, just so I can pull out that triangle and make this a little bit easier to see. So here's our 45, here's our 90, here's our 45. This is 1, and these two sides are the same length. We don't know what they are. So by using Pythagorean theorem, I can go x squared plus x squared will equal 1 squared. So when I combine my x squareds together, that'll give me 2x squared equals 1. Solving this for x, I will need to divide both sides by 2. So that will give me x squared is equal to 1 over 2. And then I will square root both sides. So I'll get x equals the square root of 1 divided by 2. Now, having this fraction underneath that radical is pretty nasty, so we can actually split this up into a square root of the top and a square root of the bottom. So square root of 1 divided by square root of 2. We know the square root of 1 is 1 over radical 2. And now to get rid of that radical in the bottom, I'll just multiply top and bottom by radical 2, which will give me radical 2 over 2. And that will be the lengths of these legs in simplest radical form, radical 2 over 2. So that means back on our unit circle that the coordinates of this point, when we rotated 45 degrees, are radical 2 over 2 for cos, and then up that same amount for sin, radical 2 over 2. And just to solidify this for you on your calculator, if I do square root of 2 divided by 2, I get 0.7071067812. Now, supposedly, when I rotate 45 degrees, the cos of 45 degrees should be radical 2 over 2, or 0.7071. And same thing for sin of 45 degrees. Let me redo that one. Sin of 45 degrees, 0.7071. So the cos and the sin are both the same, radical 2 over 2. Now, one thing to keep in mind here that's important is, yes, now we know the coordinates for 45 degrees, but we also know the coordinates for, we'll say, 135 degrees, which would be here in the second quadrant, because 135 degrees rotation has a 45 degree reference angle. And notice that this triangle over in the second quadrant, if it's 45, 45, 90, is going to behave the same way as it did in the first quadrant. These two sides are going to be the same, and my cos is going to be the same distance from here to here as it was over in the first quadrant from here to here, which is radical 2 over 2. But one thing to be careful of, that cos in the second quadrant, cos is negative, so this would be negative radical 2 over 2. And going up positive for sin will be positive radical 2 over 2. And then we could do the same thing in the third quadrant with a 180 plus 45, so a 225 degree angle. We know the cos and the sin. And the same thing is true in the fourth quadrant with a 315 degree angle. We know the cos and the sin, all based on that 45 degree reference angle.